So I'm going to finish off the TypeScript stuff today, and then we move on to the second topic. So where we finished off with was talking about generics. I don't know if you've come across this concept of generics before in other languages. I could ask you if you had or not, but I'm not sure if I get an answer. But have you come across generics before? I'll try. I'll try it anyway. Hmm. No. I kind of think you have because if you've written any Kotlin, this where is it? This kind of angle bracket stuff. I've seen that in Kotlin. I haven't written any Kotlin, but I've seen that being used. So anyway, just to quickly remind you, this idea of generics. The idea is you want to make your components reusable, but reusable this time on the basis of the data types that the component is working with. Component here could mean a class or a function or an interface data type or an alias, type alias. It's actually applicable right across the board. Um, um, which is kind of unusual, really, like this idea that you don't commit to the data types that are being used in your component until you actually use the component. In the declaration of the component, you indicate that there are certain sort of input to the component whose types you're not stating explicitly, you're leaving it open. And it's only then when you use the component uh, that you need to kind of bind an actual type to the type variables. And you might remember from Tuesday, this was the example that we had, this function. Here we're saying, look, this function is actually generics based. In particular, the first argument of the function, we're not stating what type it is. We're saying it's of type T, where T is our type variable. There's no significance to the name T, as I said to you on Tuesday. It's just a convention to use capital single letters for your type variable names. So this is in the declaration. Okay, here we're actually using the function, and here we're binding. In this case, we're binding the person data type, which let's assume we've defined that as a earlier on as a, let's say, an interface data type or type alias. We're binding it to the person type, and therefore the first parameter of this particular invocation, that parameter better be an object of type person. Otherwise, the compiler will actually complain. Second example here as well, using box. To give I was going to say to give you a real world example, but it's a kind of a makey-uppy example. If we look at our code samples, go into the generic section. So I'm kind of building up to it here now. So let's just park generics for a second so we can kind of set the context. All I'm doing here, look, this is just plain old JavaScript. I have an array of strings. Sorry, this line here. I have an array of strings, and I'm invoking the sort method on that array. And we've probably seen sort before, where we pass it a callback, and the callback kind of expresses on what basis you want this array to be sorted. And I'm just going to sort, it looks like I'm sorting my strings on the basis of the length of the string. This callback, as you know, this callback that you pass to the sort function, the callback has to return a numeric value that's just prescribed by sort itself. And that would be the case here because we're just doing simple subtraction of numbers. And by default, the sort is done in ascending order. So we'd hope that when we console log here, that the array would be what? It would be to the hello and universe. Yeah. Let's just be sure that it does. Let's run it. NPX. 03. Yeah, and that's what we get. So, sorry, here. That's fine. Okay, no generics being used there. Let's supposing I write my own sort of little wrapper function for this sorting. So I've got a function here. Again, there's no generics being used here. I've got a function called string ranker, and you pass it an array of strings, and you pass it a callback, which I've sensibly called it ranker. So this callback is a function that will control the basis on which I want my strings to be sorted. Okay, because the only thing I'm doing in the body of the function is I'm calling the sort. Okay, so there's not a lot extra going on here now, but I'm building up to generics. That's the whole point. So this ranker function, essentially that's controlling the kind of criteria that I'm using for doing my ranking. Yeah, and you can see here, again, I'm just calling sort in my array, and I'm using my ranker function on A and B, right? So it's kind of a bubble sort it's going to do. Yeah, and I'm returning the result. That's fine. And so what have I got here? I'm calling my string, sorry, I'm calling my string ranker function, and this is my array of strings. And again, I'm just using length in this case, but my ranker function could be anything really. Maybe I count the number of occurrences of the letter E in the word and rank the strings on that basis, or anything. It doesn't really matter. As long as this function, it has to return a number, because that's, as I said, that's the way the sort works. And we can see down here that works as well. I think this is the line. Yeah. So it's getting that right. Surprise, surprise. Moving on. I've got another function called person ranker, which kind of does the same thing, except it looks like it operates on an array of person objects. Now a person I've decided is this. Yeah, it's okay. And again, the body of this function is the exact same as the body of the string ranker function. So we're getting closer now to saying, couldn't we put these together? But for now, we won't put them together. And here I've got a person and another person, and I'm going to use another person, and I'm using those in my array. I'm calling the person ranker my array of persons, and surprise, surprise, I'm using their age as the criteria for sorting. I could have used the length of their surname or something like that. It doesn't really matter, although it does have to be a function that returns a number, as I said before. And that all seems to work as well, because when I look down here, look, it is ranking the persons by age in ascending order. And so the obvious question is, well, you've got two functions here that are almost identical, but they're just working on different data types. Can you bring them together? And yes, you can. That's where generics comes in. Now, just before I talk about that, though, uh, let's supposing, and again, this diversion now has nothing to do with generics. It's more, I want to illustrate another aspect of TypeScript that that's really useful. What do I mean by that? Let's supposing our person structure had age as an optional. Yeah. Now, when I go back to my code, look, I've got a red squiggly line here. So the compiler doesn't like something. And when I bring up my problems, it's saying type undefined, sorry, type undefined is not assignable to type number. Look, this one here, type number or undefined is not assignable to type number. That's probably the better one to read. Type unassigned or number is not assignable to type number. Does anybody want to have a guess at why, what is it trying to tell me there? Or what is it complaining about? So the answer to that question is, well, up here I'm saying that my ranker function has to take an object of type person and it has to return a number. But if my function is using age, where age could be undefined, then that means this simple function here, this is actually a function, right? It's an arrow function, it's a one-liner and all that, but it is my function. This function potentially could return undefined if we meet a person that has no age property assigned to them. And so the compiler is kind of warning you, look, you could be in trouble at some stage when you run this function if you happen to pass in a person object that doesn't have an age property. Right? So, and then like that's kind of classic example of the kind of stuff that happens when you're writing JavaScript, you know. If this was all in JavaScript world, we wouldn't be getting a compilation error, obviously. And we might be invoking this function, this person ranker function. We might be passing it 100 person objects, and it seems to work for some of them, but then it crashes for other ones. And we need to work out why is it crashing, and the answer would be it would be crashing or throwing a bug or not behaving properly anyway in some way for those person objects that don't have an age property in them. And we wouldn't discover that until we eventually, you know, pass it a person object with that. So now we may still want to allow age to be optional, but essentially the compiler is telling me, look, you have to deal with the case where there isn't going to be an age property in a person object. And now, so what I arbitrarily decided was, okay, the way I'm going to deal with that is like this. I'm going to say if p.age is not defined, then if it is defined, then use the person's age as the return value of this function. If it's not, then use the value 30. Again, that's just an arbitrary decision that I made, but it may be based on some logic, although I can't come up with any logic. But so anyway, the key point is the compiler has actually warned me of a potential issue with this particular function. So let's leave it there actually. Let's leave age as being optional. Now, back to generics. So I now have person ranker and string ranker doing the exact same thing. Can I bring them together? And the answer is yes, we can. And so now we move into generics. So I've now got a function called, well, not a great name, but generic ranker. Could have just called it ranker, I guess. Here's my, I'm using T again, but that's just coincidental. Here's my type variable. And the signature of the function is we pass it an array of T's, and we pass it a function that takes a T as an argument and returns a number. and then the body of the function is much the same as before. Yeah. Here we're actually invoking our generic ranker. We're setting T to person. We're passing in our array of persons, and we could let's take age out of this one, for example. Where were we? Oh yeah. Okay. Well, sorry. What am I doing? Oh yeah. That's the same as B. Yeah, that's where we're using it, and I'm using the same sort of logic here again now as before. And what am I console logging? I'm console logging that. So if I just run it again. So it's this one here. And it seems to be working okay, even though, okay, I took age out of Jill, removed age, but it's putting it as second because we're defaulting Jill's age to 30, and so that's in the right order. Okay, so admittedly, it's kind of a 101 example of generics, but you get the point, hopefully. Now, I said generics can be used, it's not just constrained to functions. We'll see it being used, I think, a little bit in classes later on, but you can use it in other scenarios as well. Oh, sorry, before I move on to that, here I'm using my generic ranker and I'm passing it an array of strings, right, just to make sure it works. And we can see, right now I'm jumping around a little bit. We can see it worked down here as well for us. But I just wanted to raise or bring to attention, like, I'm not actually specifying T at all here. Like in the person case, I told it what type T was, but I'm not actually doing it here. And that's another example of type inferencing. The compiler will infer that T is of type string. I'd say what it does is it looks at this array, it sees that it's an array of strings, and according to my definition of generic ranker, the first argument is an array of objects of type T. So T must be string in this case. And, we can kind of prove it to ourselves. Command K, Command I. Yeah, you can see it gets it right there. And I'd say it would get it right in the person case as well. Let's see if it does. Let's get rid of it here. Yeah. So as I did mention to you, type inferencing is something that you just kind of get used to. The more TypeScript you write, get used to in the sense that you don't have to be explicit about the types in your code. You can let type inferencing take over essentially, but you do need to keep an eye on it every now and again. Okay, so that's type inferencing. Sorry, that's generics with functions. Here I've got another simple example, but again, it's kind of made up example. So I've got an interface data type called microphone, another one called speaker. They're just ordinary interface data types. And I've got a box interface here, and you can see it's using generics as well. So I could have, I guess is the idea is that I could have boxes of different types of uh, content. Yeah. So a box has a shelf number and it has a content where the content is an array of T's. And down here, then I'm declaring an actual box, and I've decided it's going to be a box of speakers. And you can see that the object that I'm putting into it is the shape of a speaker. Now, I don't think generics would work out speaker because I'm not actually being explicit here. Like if I assigned this to a separate variable up here and declared it of type speaker, then it would get it right. But I'm guessing it won't get it right here. Sorry, no. I want to take speaker out of that and try. What did I do wrong? Sorry. Oh yeah, what I need to. I don't think I can do it at all, actually. Well, if I get rid of the whole lot. I can't see it getting this right. No, I don't think it's actually going to guess anything for me. Command K, Command I. No, so it's not as, we do need it there really, which would make sense actually. All right, it's just another example anyway, and I think I have a comment down here saying you can use generics in other components as well. So that's generics. A fairly quick look at it really, but I certainly wouldn't expect people to be able to, like with a lot of programming, the concepts themselves, not just TypeScript now, but any language, the concepts associated with a programming language, they tend to be easy enough to understand in isolation. The real challenge with programming is knowing when to use the concepts in a particular scenario. That's the difficult part. But so we're not going to get into that now, though, but that's just a general point about programming. Okay, that's generics. The last thing I want to look at is what are called utility types. So TypeScript, like any other language, has built-in types. It has its own built-in primitive type hierarchy, and it has some other built-in types as well. You know, the only one I mentioned to you was regex is a built-in type, and it has a few other useful built-in types. But separate as well, what it has are what are called utility types. And these can be useful. Utility type, as the kind of is being said here, a utility type is something that you would use to transform one type into another type. Okay. And if you just Google TypeScript utility types, you'll probably hit this page here, and it'll give you a list of all of the built-in utility types. There's a whole bunch of other utility types that have been developed by the community, and you'd have to kind of install those separately. But the built-in ones are the only ones I would just want to briefly look at. Certainly not going to look at all of them, but I'll just briefly mention some of the kind of more popular ones, I suppose. So we said a utility type is a type that it's a data type that you use to transform one type into another type. So, okay, here we've got an interface type called tech user. Okay, that's standard. Here, what I want to do here is I want to define a type which has all of the same properties of tech user, but I want all of the properties to be optional. At the moment, it looks like only email is optional. So I'm going to call this new type type user optional. Not a great name. Here's the utility type now. So there's a utility type called pick, and you can see it uses the kind of generic syntax. And the way you interpret this line is you take this kind of source type, tech user in my case, uh, uh, sorry, not pick, partial. Sorry, partial is the name of utility type. You take your source type, or it takes the source type, and it generates a new type, and all of the properties of that type will be taken from the source type, but they will be made optional. So in other words, if I do Command K, Command I on this, let's do it again. Command K, Command I. You can see that all the properties have the kind of question mark after them. They're all made optional. Yeah. So maybe there are cases where you need to create data structures which have some of the properties of tech user, but not all of them. A classic example would be if you wanted to update some of the properties in a tech user. And I think that's what I'm doing in this simple function here. Yeah, merge updates. Look, I'm passing it in a tech user, and I'm passing it in an object of type tech user optionals, and it kind of merges them together. So it's like an update operation on my tech user. So that's partial. The opposite, okay, that's the console log. You can look at that yourselves. The opposite is a utility type called required. It takes all of the properties of this source type and it makes them mandatory. And then that's the new type. So I'm transforming that into this. And again, email was the only one, but we can see email is mandatory here now in this case. Pick is another utility type. And what it does is it picks out particular properties of your source type and it puts all of those into your new type here. So my new type is called, I don't know, minimal tech user. I wasn't great at coming up with names whenever I wrote this. So I want to take the email and the name, just those two properties, out of tech user. And again, Command K, Command I. Doesn't always work for me. Command K, Command I. Yeah, gets it right. Now, you might think, it's hardly worth the effort. Could you not just define minimal tech user long-handed? Yes, you could, but the idea is, I guess, is that you're kind of you're forming a relationship between one type and another, and that happens a lot in kind of real-world problem domains. And so we're kind of maintaining that relationship here between minimal tech user and tech user, just in case maybe later on somebody added some more properties to tech user, and maybe some of those new properties we wanted to put into minimal tech user. Well, we just come down to this declaration here and it would take care of it for us. The opposite of pick is a utility type called omit. Here's omit. Oh, and so what it does is it takes this list of properties here, it removes them from tech user, and the result then it puts into your new type. It's unfortunate now that this is really, you really interpret this as an and rather than an or. Similarly with the pick, you interpret it as an and rather than an or. I guess there was some reason why the designer, where's pick gone to? Where's pick? There, yeah. you kind of interpret that as and as well. But okay, it's not that big a deal, but moving on, the last one I look at is record, which can be a tricky one to explain, but let me just show you. If I run this script, let's supposing I want to create an object like this, okay, and I want to tell TypeScript something about the data type of this object. Now, the object in this case, the keys are the IDs of a tech user, and the value associated with each key are a subset of the tech user's properties. Um, I think it's okay. So that's what I want. I want to describe this object in terms of its type structure some way. Now, I can't use the interface data type because with the interface data type, you have to know what the keys are beforehand. And I won't in this case because, if I've got 50 users or tech users or 60 tech users, the keys are just going to be their IDs. I won't know the exact tech users that I have before I run my application. Okay, so that won't work. Type aliasing won't work. The way you do it is to use this record utility type. And that's what we're doing here. Yeah, here, right? So the first thing I've got to tell us, the first kind of argument, if you like, that I need to pass to record, okay, is the type for the keys. And I want to link the type to be, I want to link it to the type of the ID property in tech user. That's how you interpret this. This is just standard JavaScript, actually, where you can use the subscript syntax to reference a particular property in an object. Now, the object in this case is a data type, it's an interface data type, but I'm referencing the ID property. And I think earlier on, ID was a number, yeah. Now, but because we're actually using it as a key in an object, it is going to be kind of wrapped as a string. But the contents of that string will be numbers, and there will be the number associated with a tech user. The value then, I'm just using one of the types that I've defined earlier on. So programming or tech user programming, I've actually that defined here, right? So tech user programming looks like this, and we've talked about this before. So that's what this record utility type can be useful for defining the shape of an object where you kind of know something about the keys. You don't know what the exact values of the keys are, but you know what type they will be. And you also know what type the values attached to those keys will be. Yeah. Now, to demonstrate it, then all I'm doing here is I've got a function here which takes an array of tech users and it returns an instance of this object that I've just defined for myself. And I'm just using I'm using the reduce method. I'm iterating over my array of users and I'm building up my object. Essentially, I'm building up, I'm building up this object here. Okay, so that's just, that's just JavaScript reduce method. Here I'm actually invoking that method and I'm passing in an actual array of tech users. Okay, an array of 2, but right. That's that. You can have a look at it yourselves later on if you need to kind of clarify for yourself what this record is all about, this record utility type. Okay, that's all I'm going to do with TypeScript, and it's enough to allow us to be able to read fairly standard TypeScript, admittedly. And it's also probably enough to be able to allow us to progress to study what we really want to study, which is cloud app development. So if I go back to the website, just go in here now. So you do have enough information now to be able to finish this lab. You may have finished it already. So the next topic that I want to look at is Cloud Development Kit. So we're moving completely away from programming now, and we're moving into the area of cloud and provisioning infrastructure in the cloud. So we're moving a long way away from it. But we're actually going to provision our infrastructure using code. And for no particular reason, other than we've just looked at TypeScript, we're going to write our infrastructure provisioning code in TypeScript using this framework called the CDK framework. There's a lab. Now, there's two, well, there's really just one lab, but this one here steps you through creating an IAM user in your AWS account, which is, you probably know this from last year now, right? You know, when you're using, well, last year actually you used a learner account. So this year you'll be using your own personal account. It's recommended that when you're using your own personal account, and certainly when you're using it to on the web, like using the management console, the AWS management console, that you should not really log in using your root user privileges. What you should do is create an IAM user, give that IAM user the privileges that they need, and then log into the AWS Management Console using that IAM user credentials. It's just considered best practice. So here I'm showing you how to create an IAM user if you don't know how to do it already. So you should probably do that first and then move on to this lab. Although given the time that we are right now, I'm not going to get enough done. Certainly not going to get enough done today to allow you to fully understand what's going on in this lab, other than you could just do the startup part. The startup part, which is what's called CDK bootstrapping, if you want to. There's very little involved in it, but if you want, you can do that. You could certainly do all the lab. It's very prescriptive, so there's no exercise involved in this lab. You're not handing this lab up. So it's up to you. Okay. I first need to talk about this CDK framework, though. So CDK stands for Cloud Development Kit. It's a framework for automating the creation of infrastructure, cloud infrastructure. In relation to creating cloud infrastructure, we want to make sure, or we'd like anyway, that whatever means we go about to create infrastructure in our cloud platform, in our case, AWS, but it's not unique to AWS, whatever approach we use, we'd like that approach to be reliable and consistent. Why do we want that? Well, the infrastructure that we want to create in the cloud, we may want to replicate that infrastructure a number of times. Maybe because we want to use the exact same infrastructure in development environment as we do in a test environment, in the QA environment, in the staging environment, in the production environment. So there may be a number of different kind of contexts or environments from a software development point of view where we want to replicate the exact same cloud infrastructure. By cloud infrastructure, I simply mean, you know, an S3 bucket that's configured in a certain way, an EC2 instance that's configured in a certain way. Okay, so because we want to do it multiple times, then we want to make sure that it's the exact same infrastructure that's being created each time. Also, you know, if we're deploying an application to the cloud, we know in the case of AWS and in the other cloud platforms as well, AWS breaks the AWS cloud into regions, geographical regions. So in order to make our application accessible and performant for everybody across the globe, we may actually want to deploy our application into multiple regions, not just one region. Everybody would be able to access across the globe if it was only deployed in one region, but clearly there would be greater latency if you're accessing it from a region that it's not deployed in. So by the same measure, the infrastructure that we deploy into each region that we want to, the infrastructure that we create in each region that we want to deploy our application to, it has to be the exact same infrastructure. We want consistency and reliability in that creation process. The solution to that consistency certainly isn't to have a manual approach to it. No matter how well you might document the manual steps, you know, if you want to change the infrastructure, you've got to make sure that the manual is updated and everybody has the most up-to-date version of the document and all that sort of stuff. So it's not a runner. So a manual approach is not satisfactory. We'd like to automate it. Automate it means script it in some way. And then you just run the script, and the script creates the infrastructure up in the cloud, as we say. That script or that code is what we refer to as infrastructure as code. It's code which generates or creates infrastructure in the cloud. And so the benefit of automating it and scripting it or representing it in code are, you know, it's code, so we can store it in a GitHub repository. We can have version control over changes to that code because the code may well change because we want the infrastructure to change. If we make changes and that causes our infrastructure or the application that we're running on the infrastructure to not work properly, then we want to roll back the infrastructure. That's meat and drink to something like Git and GitHub. And we always talk about this idea of a single source of truth. So everybody is using the same GitHub repo to create the infrastructure for the different environments in the different regions. So we have all of those benefits of using source control on our code. Yeah, okay. So this idea of infrastructure as code has been around for quite a while. Now, in the very early days, the way you went about it was you wrote a Python script. It tended to be nearly always Python. Now, what the Python script did was the Python script used an SDK, a software development kit, which was provided by the cloud provider, AWS in our case. Let's just narrow it down to AWS, but they all do the same. And the SDK provided by the cloud provider, it took care of communicating with the different services like EC2, S3, SQS, IAM, or all those services. So the SDK took care of that low-level communication, and the communication was just across HTTP. And also what the cloud providers did was they wrapped each of the services in a web API, or they provided a web API interface to each of the services, a RESTful web API, as it turns out. We know a lot about REST from last semester. So each of the services has a RESTful web API interface. And the cloud providers also published or made available open source an SDK that took care of the kind of low-level HTTP communication with the web APIs of the various services, simply because so that you don't have to in your code. Your code then, and it was nearly always Python on day one, in the early days anyway, your Python code simply used the SDK in order to get the services to create the infrastructure that you needed. But there were lots of problems with that approach. For example, if halfway through the execution of your Python script, for whatever reason, your Python script crashed, that now means some of the infrastructure has been created, but some of it hasn't. So you've got to go back and manually destroy the infrastructure that has been created and try and, fix the bug in your code and run it again. And even if it does run successfully, okay, it's now created the infrastructure. But supposing you want to make some updates to the infrastructure, you essentially have to kind of create a new script, because this Python script won't do. You can't run this again because that's going to go away and create all the infrastructure all over again. So there was lots of problems really with this approach. Okay, as a proof of concept, it worked fine, but there were problems that I'm kind of listing down here. To solve that problem, all of the cloud providers created a new service called a resource provisioning engine. And you may know a lot about this stuff already, but I'm just making sure that we're all starting on the same page kind of before we move on too far in this topic. So now just let me check time again for 1 second. Okay. So this resource provisioning engine solved some of the problems with the previous slide. In the case of AWS, the cloud provisioning engine, the resource provisioning engine is the CloudFormation service, and I'm assuming that you've at least heard of that and may have used it a little bit in the automated cloud services. And if you haven't, it's not a problem. So now we no longer were writing Python scripts. What we now did as developers, I guess, is we wrote what was called a CloudFormation template in either YAML or JSON, which is, in other words, it's using a declarative syntax. And in this template, we are essentially declaring the state of the infrastructure that we desire. For example, we want an EC2 instance with a particular set of configuration settings. We want an IAM policy with a particular configuration, and so on. And it doesn't matter what order in which we put those declarations, okay? So we write this template in YAML. We simply upload that template to the CloudFormation service, and it essentially used the SDK to talk to the other services, asking them to create the particular piece of infrastructure that was requested kind of in the template. And, there weren't really issues with if things break down halfway through, because the CloudFormation service would retry if things failed. Now, of course, there may still be cases where the CloudFormation service cannot complete the creation of the infrastructure. And if that arises, it will actually roll back everything that it's done for you. So you don't have to do that. Let's supposing it did actually create all the all of the infrastructure was created properly. Now you want to make some changes to the configuration of certain parts of that infrastructure. All you've got to do is come into, get your YAML file, make the necessary edits to that, give that to CloudFormation. It actually works out what are the differences between the new version of the template and the old version, or put another way, what is the difference between the new state that the user is looking for and the current state of the infrastructure. It actually does that diff operation. And based on the results of that diff operation, it communicates with the relevant services, asking them to make changes to the configuration of the particular pieces of infrastructure. So it's doing all of the heavy lifting for us. Just down here, although I don't want to get into it, a separate company called HashiCorp, they developed the problem with CloudFormation is that it's AWS specific. The other cloud providers, okay, they had their resource provisioning engine, uh, which were also understood this kind of templating approach. But there were differences between their cloud provisioning engine because the services that they had might be slightly different. So you couldn't use the template that you had written for an AWS platform. Obviously, I guess you couldn't use that with any of the other cloud providers like Azure or Google Cloud. But what HashiCorp did, this company, is they allowed us to write a template, and we could state on the template what cloud provider do we want to um, use this template with, and a separate kind of service called or a framework called Terraform took your HashiCorp template written in a language called HCL, took that, generated the YAML that was appropriate for the particular resource provisioning engine, let's say CloudFormation, and then the rest took it from there. So the nice thing about the HashiCorp solution was that it was cloud agnostic, whereas this is cloud specific. Now we're not going to look at HashiCorp, but we're not going to look at Terraform, but it's part of the story of infrastructure as code. So that was a huge leap in our infrastructure as code kind of journey or objective. And there were still some issues though, and I'll finish on this point now. There were still some disadvantages, mainly from a developer experience perspective, because you're writing this YAML code, and the YAML could be quite long and quite verbose. So it just became a bit of a headache, really, in terms of developing this stuff. Okay, there are some tools built into IDEs that maybe can help you, but overall, it wasn't as kind of enjoyable as writing imperative code. Imperative code are the kind of languages that we're familiar with. Declarative code, which is what YAML and JSON is, and there are other declarative languages as well. They're a little bit more challenging, really, to develop. Also, you know, the YAML code that you wrote, you essentially kind of had to define every particular part of your infrastructure. There were no kind of high-level abstractions, which typically abstractions allow you to, not need to write as much code as you would when you don't have abstractions. So there weren't any abstractions available in this CloudFormation templating model, which was kind of a drawback as well. And those two disadvantages brought us on to kind of the next evolution of infrastructure as code, which is where we use an imperative programming language like TypeScript, Python, JavaScript, Java, Rust, Kotlin, any one of them. And in the case of the AWS platform, we need to use this framework called the Cloud Development Kit. We don't write kind of raw imperative code as we did back in the early days of infrastructure as code. We write our code and use it in the context of the CDK framework. And the CDK framework has lots of really nice abstractions, which means we don't have to write as much infrastructure code, certainly not as much as the kind of YAML or JSON approach. Now, I'm going to have to park it there, which means we haven't really looked at anything in relation to the CDK. In relation to the lab, you can still complete the bootstrapping part of the lab. You can be ambitious and have a go at the rest of the lab. The only thing I'm slightly nervous about, though, is this lab involves creating, this part of the lab involves creating this fairly elaborate infrastructure here, which is all based around EC2 and application load balancers, etc., which are um, which are infrastructure that you may be familiar with from the automated cloud services. The problem, though, is if you create this infrastructure and you just leave it there, you're going to be incurring costs, even though you're not using the infrastructure. So I'm almost tempted to say, don't work your way through this lab. If you do, you have to make sure that you jump forward. Like if you work your way through it and everything is working fine, then as quickly as you possibly can, jump to this cleanup part. There's only one line of code that you execute in the cleanup, which is this one. And what it does, this is a command that you execute from just within your VS Code. What this does is, as the name suggests, it destroys all of the infrastructure that you've created. But I'm almost inclined to say don't bother doing any of it right. Just do the bootstrapping okay if you want to. And certainly create your IAM user. Outside of that, then uh, take a break. Okay, I will leave it at that. I will turn up at the lab tomorrow. If you're there, that's fine. If you've completed the TypeScript lab already, you can still turn up. I'm not going to be taking attendance or anything like that, but I will be there anyway. Right, I'm over time really, so I'm going to park it at that, and I will hang around if there are any questions. Some people might be ambitious and want to ask me one or two things about this lab. I'm happy to hang on for a little bit. If you don't, that's fine. And you can contact me on, if you want, and maybe tomorrow you could have a crack at this lab. That's the only thing that just came to mind now, because then at least I'll be there to kind of supervise it with you, but make up your own mind. Right, that's it. I will maybe talk to you tomorrow. Bye for now.